Okay, guys, this is example 7. Again, we didn't get to this one in class, but I just wanted to do it real quick. This one's actually surprisingly easy. Manufacturer of corrugated panel roofing wants to produce C panels that are 28 inches wide and 2 inches thick by processing flat sheets of metal as shown in this figure. The profile of the roofing takes the shape of the sine wave, y equals sine pi over 7x. Find the width, W, of a flat metal sheet that is needed to make a 28-inch panel. Assume the process does not stretch the material. Round to 3 decimals. Yippee. Okay, well, what they're asking for is just the length. We want to know the arc length of this funky little shape, right? So we got to go back. What is our formula, right? Length equals integration a to b square root of 1 plus. I'm going to write it a different way so you see it a couple of different ways. y dx squared. X, right? Y prime squared, dy dx squared. These are all meaning the same thing, okay? We're just using the arc length formula. So what do we need to know in this? Well, they gave us y equals sine pi over 7x. We're going to need to know dy dx. So we need to evaluate that, right? They gave us y. We now need to come up with the derivative of that. So what's going to be the derivative of this function? Well, we take the inner part, pi over 7x. What's the derivative of pi over 7x? That's just going to be pi over 7, right? Times the outer function, sine of all of this. What's the derivative of sine? That's cosine. And then we include what's inside. There we go. There's the derivative. I know that was challenging, but we've got it. So now, what do we got to do? We got to take the integration. So length equals the integration. I'm going to leave the upper and lower bounds empty for just a moment here. 1 plus, and we're going pi over 7 cosine pi over 7x squared. Oh, I'm sorry, I forgot my other parentheses. There we go. Now the question here is, where are we going from? Well, they have a 28-inch long sheet or panel. They want to know how big it's got to be. They want to know the length, the arc length of that sheet. So we want to go from 0 to 28 inches along this wavy function. We want to know how long we're traveling along this, okay? The nice thing about this is that they told us that it was 2 inches thick. What does that mean for us? That means that the amplitude of the sine function is 1. What's the amplitude? The amplitude is the distance that the curve travels from the midline, okay? The amplitude has to be even. So there has to be a consistent amount that it goes up and down. If the distance, the total distance that the curvature of this thing goes up and down is 2 inches, we take the total distance, divide by 2. That means it's going up by an inch and down by an inch, okay? It's not going to impact. The amplitude is only going to be an inch on either side, okay? So fortunately enough for us, that's not going to impact our function all that much. So the length equals the integration from 0 to 28 of the square root of 1 plus pi over 7 cosine pi over 7x squared dx. If the amplitude was a higher number, we may have to consider that in our function, but we don't have to consider that in the function because the amplitude is only 2. Now, what do we do from here? Well, quite frankly, what I would do is punch this into a calculator. You want to be careful about this pi over 7 cosine pi over 7x when you're punching it into the calculator. You want to make sure that you've got parentheses in the right kind of places. So that way you're not, you're squaring just this portion of the function and not that extra plus 1. If you square that extra plus 1, it's going to throw your values off by a little bit. But if you punch it into a calculator and you punch it in properly, which I suggest you all try doing, you should get 29.361 inches. Okay, we wanted it to 3 decimals, and that's what we did. 29.361 inches. Okay? And that's example 7. It's really not that hard. We've been practicing arc length a little bit, and this is a practical question that you could see on a test. It's not too bad. Again, if you have questions, please let me know.